To another YouTube video, and today I'll be covering Nmap live host discovery, and we'll be learning how to use Nmap to discover live hosts using ARP scan, ICMP scan, and TCP UDP ping scan. So on task 1 for the introduction, when we want to target a network, we want to find an efficient tool to help us handle repetitive tasks and answer the following questions. 1. Which systems are up? 2. What services are running on the systems? The tool that we will rely on is Nmap. The first question about finding live computer is answered in this room. This room is the first in the series of 4 rooms dedicated to Nmap. The second question about discovering running services is answered in the next Nmap rooms that focuses on port scanning. This room is the first of 4 in this Nmap series. These 4 rooms are also part of the network security module. Nmap live host discovery, Nmap basic port scans, Nmap advanced port scans, and Nmap post port scans. This room explains the steps that Nmap carries out to discover the systems that are online before port scanning. This stage is crucial because trying to port scan offline systems will only waste time and create unnecessary noise on the network. We present the different approaches that Nmap uses to discover live hosts. In particular, we cover 1. ARP scan. This scan uses ARP requests to discover live host. 2. ICMP scan. This scan uses ICMP requests to identify live host. And 3. TCP UDP ping scan. This scan sends packets to TCP ports and UDP ports to determine live host. We also introduce 2 scanners, ARP scan and mass scan, and explain how they overlap with part of Nmap's host discovery. As already mentioned, starting with this room, we will use Nmap to discover systems and services actively, and Nmap was created by Gordon Lyon Fedor, a network security expert and open source programmer. It was released in 1997. Nmap, short for Network Mapper, is free open source software released under GPL license. Nmap is an industry standard tool for mapping networks, identifying live hosts, and discovering running services. Nmap's scripting engine can further extend its functionality from fingerprinting services to exploiting vulnerabilities. A Nmap scan usually goes through the steps shown in the figure below, although many are optional and depend on the command line arguments you provide. 1. Enumerate targets. 2. Discover live hosts. 3. Reverse DNS lookups. And 4. Scan ports. And 5. Detect versions. 6. Detect OS. 7. Trace route. 8. Scripts. And 9. Write output. Moving on to answer the question below. Some of these questions will require the use of statistics site to answer the task questions, while others require the use of the attack box and the target virtual machine. And just click complete, and we're moving on to the next section. Task 2, subnetworks. Let's review a couple of terms before we move on to the main task. A network segment is a group of computers connected using a shared medium. For instance, the medium can be Ethernet switch or Wi-Fi access point. In an IP network, a subnetwork is usually the equivalent of one or more network segments connected together and configured to use the same router. The network segments refers to a physical connection, while a subnetwork refers to a logical connection. In the following network diagram, we have 4 network segments or subnetworks. Generally speaking, your system would be connected to one of these network segments / subnetworks. A subnetwork, or simply a subnet, has its own IP address range and is connected to a more extensive network via a router. There might be a firewall enforcing security policies depending on each network. So it's referring to this right here. As you can see, you have the 4 networks. The figure above shows 2 types of subnets. Subnet with /16, which means that subnet mask can be written as 255.255.0.0. This subnet can have around 65,000 hosts. Subnet with /24, which indicates that subnet mask can be expressed as 255.255.255.0. This subnet can have around 250 hosts. You might want to refer to task 2 in the Intro to LAN room if you need to learn more about subnetting. Also, if you do need to, I do have a YouTube tutorial on this one specifically. As part of active reconnaissance, we want to discover more information about a group of hosts or about subnet. If you're connected to the same subnet, you would expect your scanner to rely on ARP, Address Resolution Protocol, queries to discover live hosts. An ARP query aims to get the hardware address MAC address so that the communication over the link layer can be possible. However, I'm sorry, just got a little lost here. However, we can use this to infer that the host is online. We revisit link layer in task 4. If you're in the network A, you can use ARP only to discover the device within the subnet 10.1.100.0/port 24. Suppose you're connected to a subnet different from the subnet of the target system. In that case, all packets generated by your scanner will be routed via the default gateway router to reach the systems on another subnet. However, the ARP queries would be routed and hence cannot cross the subnet router. ARP is a link layer protocol and ARP packets are bound to their subnet. Click on View Site button to start Network Simulator. We will use the simulator to answer the questions in tasks 2, 4, and 5. So we're going to go ahead and get started. So moving on to answer the questions below. Send packets with the following information. So we're going to scroll down, computer 1, and I'm going to change that to ARP request. Put computer 6 on here. We're going to send the packets. As you could see, it was 4 packets that it sent. So how many devices can see the ARP request? So it was 4, as I just mentioned. Oh yeah, so did computer 6 receive the ARP request? Which it didn't. I'm gonna just go ahead and show y'all. The router is not sending it, so just put in no. So now we're gonna move on. We have to change this now. Send a packet with the following information now. So we're moving this to computer 4. Same thing, ARP request, computer 6. So now we're going to send the packets. Let's check out what happens. As you can see, we got an ARP response. Hey computer 4, I am computer 6. So that one was successful. So how many devices can see the ARP request? That's 4. We're not counting the switch. Did computer 6 reply to the ARP request? We put yes because it did. And we are free to move on to the next one. Moving on to task 3, enumerating targets. We mentioned the different techniques we can use for scanning in task 1. Before we explain each in detail, but put it into use against a live target, we need to specify the target we want to scan. Generally speaking, you can provide a list, a range, or a subnet example of target specification.
specifications are list machine IP right here, scam.org, example.com, will scan 3 IP addresses, range from 10.11.12.15/20. Will scan 6 IP addresses, 10.11.12.15 and 10.11.12.16 and 10.11.12.20. Subnet machine / port 30 will scan 4 IP addresses. You can also provide a file as an input for your list of targets. If you want to check the list of hosts that Nmap will scan, you can use the Nmap /SL targets. This option will give you a detailed list of the hosts that Nmap will scan without scanning them. However, Nmap will attempt a reverse DNS information to the pen test. If you don't want Nmap to the DNS server, you can add /n. Launch the attack box using the Start Attack Box button. Open the terminal when the attack box is ready and use Nmap to answer the following. So we're moving on to answer the following questions. What is the first IP address Nmap would scan if you provide 10.10.12.135/29? So let's go ahead and type it in. So we got, I'm sorry. Alright, it's asking for what is the first IP address. So this is the first IP address I'm getting, so I'm gonna type that in. Let's go ahead and type it in instead. So 10.12. Oh damn. .8, and we got it correct. Alright guys, moving on to the next one. How many IP addresses will Nmap scan if you provide the following range? So let's go ahead and try this now. Alright, 1 second. So we're going to type in Nmap /SL 10.10.0. Oh, I made a mistake. 0. /255 dot /125. Enter. And it is starting Nmap report now. And here you go. Here's the answer, 6,400. So 6,400 submitted. And we are correct. Now we're free to move on to the next one. Alright guys, moving on to task 4, discovering live hosts. Let's revisit the TCP/IP layers shown in the figure next. We will leverage the protocols to discover the live host. Starting from the bottom to the top, we can use ARP from link layer, ICMP from the network layer, TCP from the transport layer, and UDP from the transport layer. Before we discuss how scanners can use each in detail. We briefly review these for protocols. ARP has one purpose, sending a frame to the broadcast address on the network segment and asking the computer with a specific IP address to respond by providing its MAC hardware address. ICMP has many types. ICMP ping uses type 8 echo and type 0 echo reply. If you want to ping a system on the same subnet, an ARP query should precede the ICMP echo. Although TCP and UDP are transport layers for network scanning purposes, a scanner can send a specially crafted packet to common TCP or UDP port to check whether the target will respond. This method is efficient, especially when ICMP echo is blocked. If you have closed the network simulator, click on the View Site button in Task 2 to display it again. So we're going to move on now to answer the questions below. Send packet with the following. Alright, so we're going to go from computer 1 to computer 3. Packet type, it's a ping request. And there's nothing that says I need to fill out data. So what is the type of packet that computer 1 sent before ping? Alright guys, so it's actually an ARP request right here, the answer to this. Moving on to the next one, what is the type of packet that computer 1 received before being able to send the ping? So that's going to be an ARP response. Moving on to the next one, how many computers responded to the ping request? And that's only one. Moving on to the next one, send a packet with the following. So from computer 2 to computer 5, packet type ring request, so we're gonna send it now. Alright, let's check what it said. So what is the name of the first device that responded to the first request? That's actually the router. So routing says routing computer 2 says computer 5 is not on my local network and sending to a gateway network. So it is the router. What is the name of the first device that responded to the second ARP request? Check it out. Who has the router tell computer 2? We have an ARP response. Hey router, hey computer 2, I am router. Ping, sending ping request packet from computer 2 to computer 5. Was this ARP request? Hey router, I am computer 5. So what is the name of the first device that responds to the second ARP request? So that is computer 5. Alright, must have mistyped this right here. Computer 5. Alright, so send another ping request. Did it require a new ARP request? And that's actually no. Alright guys, so now we have completed and we are free to move to the next one. Moving on to task 5, Nmap host discovery using ARP. How would you know which hosts are up and running? It is essential to avoid wasting our time port scanning an offline host or an IP address not in use. There are various ways to discover online hosts. When no host discovery options are provided, Nmap follows the following approaches to discover live host. When a privileged user tries to scan targets on the local network, Ethernet, Nmap uses ARP request. A privileged user is root or a user who belongs to sudoers and can run sudo. When a privileged user tries to scan target outside the local network, Nmap uses ICMP echo request, TCP acknowledge to port 80, and TCP SYN synchronized to port 443, and ICMP timestamp request. When an unprivileged user tries to scan targets outside the local network, Nmap resorts to a TCP three-way handshake by sending SYN packets to port 80 and 443. Nmap by default uses a ping scan to find live host, then proceeds to scan live host only. If you want to use Nmap to discover online host without port scanning, the live system you can issue is Nmap/SN targets. Let's dig deeper to gain a solid understanding of the different techniques used. ARP scan is possible only if you are on the same subnet as the target system. On an Ethernet 802.3 and Wi-Fi 802.11, you need to know the MAC address of any system before you can communicate with it. The MAC address is necessary for the link layer header. The header contains the source MAC address and destination link layer header. The header contains the source MAC address on the destination MAC address among other fields. To get the MAC address, the OS sends an ARP query. A host that replies to ARP queries is up. The ARP query only works if the target is on the same subnet as yourself. On the same Ethernet Wi-Fi, you should expect to see many ARP queries generate during an Nmap scan of a local network. If you want Nmap only to perform an ARP scan without port scanning, you can cause Nmap/PR/SN targets where /PR indicates that you only want an ARP scan. The following example shows Nmap using ARP for host discovery. Without any port scanning, we run Nmap/PR/SN and the machine IP, which in this case is 10.10.210.6/port number 24 to discover all the live systems on the same subnet as our target machine. In this case, the attack box had the IP address of 10.10.210.6 and it used the ARP request to discover the live host on the same subnet. ARP can scan works as shown in the figure below. Nmap sends ARP requests to all the target computers and those online should send an ARP reply back. If we look at the packets generated using a tool such as TCP dump or Wireshark, we will see network traffic similar to figure below. In the figure below, Wireshark displays the source MAC address, destination MAC address, protocol, and query related to each ARP request. The source address is the MAC address of our attack box, while the destination is the broadcast address, as we don't know the MAC address of the target. However, we see the target IP address, which appears in the info column. In the figure, we can see that we are requesting the MAC address of all IP addresses on the subnet target. Subnet starting with 10.10.210.1. The host with the IP address we are asking about will send an ARP reply with its MAC address, and that's how we will know that's it online. Talking about ARP scans, we should mention a scanner built around ARP queries. ARP scan, it provides many options to customize your scan. Visit the ARP scan wiki for details, information. One popular choice is ARP scan / localnet or simply ARP scan /l. This command will send ARP queries to all valid IP addresses on your local network. Moreover, if your system has more than one interface and you are interested in discovering the live host on one of them, you can specify the interface using /i. For instance, sudo arp scan /i etho/1 will send ARP queries for a valid IP addresses on the etho interface. Note that ARP scan is not installed on the attack box. However, it can be installed using apt install ARP scan. In the example below, we scan the subnet of the attack box using ARP scan attack box and attack box IP /24, which is this is the IP that it's talking about. Since we ran this scan at the time frame close to the previous one, Nmap /PR/SN, we obtained the same 3 live targets, which it's this that it's talking about. Similarly, the ARP scan will generate many ARP queries that we can see using TCP dump, a Wireshark, or a similar tool. We can notice that the packet capture for ARP scan and Nmap /PR/SN yields similar traffic patterns. Below is the Wireshark output. If you have a closed network simulator, click on the Visit Site button in Task 2 to display it again. Alright, moving to answer the question below. We will be sending broadcast ARP requests to packets with the following options. So we're going to go from computer 1 to computer 1. Packet type is ARP request and data type. So we're trying all of these. So we're going to go try computer 2. Let's check it out. So we have one response there. Let's try computer 3 now. Send packet. Computer 3 sends a response. Let's check out computer 4. Sending packet. There's no response there. Let's try computer 5. Nothing there. 6. don't think you could do that one either. Let's try switch 2. Nope. And I'll just try router. There you go. We got 3 responses back. Moving on to task 6, Nmap host discovery using ICMP. We can ping every IP address on the target network and see who would respond to our ping. ICMP type 8/echo request with a ping reply. ICMP type 0. Simple, isn't it? Although this would be the most straightforward approach, it is not always reliable. Many firewall blocks ICMP echo. New versions of MS Windows are configured with a host firewall that blocks ICMP echo requests by default. Remember that an ARP query will precede the ICMP request if your target is on the same subnet. To use ICMP echo request, discover live host at the option /PE. Remember to add /SN if you don't want to follow that with a port scan as shown in the following figure. An ICMP echo scan works by sending an ICMP echo request and expects the target to reply with ICMP echo reply if it's online. So here we go, you have an ICMP echo request and an ICMP echo reply. In the example below, we scan the target subnetting using Nmap /PE/SN and the machine's IP/port 24. This scan will send ICMP echo packets to every IP address on the subnet. Again, we expect live host to reply. However, it is wise to remember that many firewalls block ICMP. The output below shows the results of scanning the virtual machines class C subnetting using sudo nmap /PE/SN machine IP and /port number 24 from the attack box, as you can see right here. The scan output shows the 8 hosts are up. Moreover, it shows their MAC address. Generally speaking, we don't expect to learn the MAC address of the targets unless they are on the same subnet as our system. The output above indicates that Nmap didn't need to send ICMP packets, as it confirmed that these hosts are up based on the ARP response it received. We will repeat the scan above. However, this time we will scan for a system that belongs to a different subnet. The results are similar but without the MAC addresses. If you look at the network packet using a tool like Wireshark, you will see something similar to the image below. You can see that we have one source IP address on a different subnet than that of the destination subnet, sending ICMP echo requests to all the IP addresses in the target subnet to see which one will reply. Because ICMP echo requests tends to be blocked, you might also consider ICMP timestamp or ICMP address mask request to tell if a system is online. Nmap uses timestamp request ICMP type 13 and checks whether it will get a timestamp reply. ICMP type 14 adding the /pp option tells Nmap to use ICMP timestamp request. As shown in the figure below, you expect live host to reply. In the following example, we run nmap /pp/cn IP address 10.10.68.220/port 24. Similar to the previous ICMP scan, this scan will send many ICMP timestamps requests to every valid IP address in the target subnet. In the Wireshark screenshot below, you can see one source IP address sending ICMP packets to every possible IP address to discover online host. Similarly, Nmap uses addresses, makes queries ICMP type 17, and checks whether it gets an address mask reply ICMP type 18. This scan can be enabled with the option /PM as shown in the figure below. Live hosts are expected to reply to ICMP addresses masks requests. In an attempt to discover live hosts using ICMP addresses, mask queries, we run the command nmap /PM, and the IP address is 10.10.68.220/24. Although based on earlier scans, we know that at least 8 hosts are up. This scan returned none. The reason is that the target system or firewall on the route is blocking this type of ICMP packet. Therefore, it is essential to learn multiple approaches to achieve the same result. If one type of packet is being blocked, we can always choose another to discover the target network and services. Although we didn't get any reply and could not figure out which hosts are online, it is essential to note that this scan sent ICMP addresses mask requests to every valid IP address and waited for a reply. Each ICMP request was sent twice, as we can see in the screenshot below. Alright, moving on to answer the questions below. What is the option required to tell Nmap to use ICMP timestamp to discover live hosts? That's /pp. Next, what is the option required to tell Nmap to use ICMP addresses masked to discover live hosts? That's /PM. Moving on to the next one. What is the option required to tell Nmap to use ICMP echo to discover live hosts? That's /PE. Moving on to task 7. Nmap host discovery using TCP and UDP. TCP, synchronized ping. We can send packets to the scene synchronized flag set to a TCP port 80 by default and wait for a response. An opponent port should reply with scene or scene/acknowledge. A closed port would result in a RST or reset. In this case, we can only check whether we will get any responses to interfere with whether the host is up. The specific state of the port is not significant here. The figure below is a remainder of how a TCP three-way handshake usually works. Sorry about that. But here it is. You have your synchronize, your sync, and your acknowledgement. And then once again, you have your acknowledgement. If you want Nmap to use TCP scene ping, you can do so via the option /PS followed by the port number, range, list, or a combination of them. For example, /PS21 will target port 21, while /PS21 24/25 will target ports 21, 22, 23, 24, and 25. Finally, PS80 and 443 and 8080 will target 3 ports, 80, 443, and 8080. Privileged users, root, and sudoers can send TCP SYN packets and don't need to complete the TCP three-way handshake, even if the port is open and is shown in the figure below. Unprivileged users have no choice but to complete the three-way handshake if the port is open. Nmap, and I'll just open this up so y'all could see a little better. We will run nmap /ps/sn 10.10.68.220 at port 24 to scan the target virtual machine subnet. As we can see in the output below, we were able to discover 5 hosts. Let's take a closer look at what happened behind the scenes by looking at the network traffic on Wireshark. In the figure below, technically speaking, since we didn't specify any TCP ports to use in the TCP ping scan, Nmap used common ports. In this case, it is TCP port 80. Any services listening on port 80 is expected to reply indirectly in indicating that the host is online. Sorry about that. So just a little view of the screenshot right here. Moving on, TCP ACK ping. As you have guessed, this sends a packet with an ACK flag set. You must be running Nmap as a privileged user to be able to accomplish this. If you try it as an unprivileged user, Nmap will attempt a three-way handshake. By default, port 80 is used. The syntax is similar to TCP SYN ping/PA would be, followed by a port number, range, list, or a combination of them. For example, consider /PA21, /PA21, /PA25, and /PA80 at 443/8080. If no port is specified, port 80 will be used. The following figure shows that any TCP packet with an ACK flag should get a TCP packet back with a reset flag set. The target responds with the reset flag set because TCP packet with the ACK flag is not part of any ongoing connection. The expected response is used to detect if the target host is up. In this example, we run sudo nmap /PA/SN IP address 10.10.68.220 at port 27. Discover the online host on the target subnet. We can see that the TCP ACK ping scan detected 5 hosts as up. We peek at the network traffic as shown in the figure below. We will discover many packets with the ACK flag sent to port 80 of the target systems. Nmap spends each packet twice. The system that doesn't respond are offline or inaccessible. UDP, finally, we can use UDP to discover if the host is online. Contrary to TCP SYN ping, sending a UDP packet to an open port is not expected to lead to any reply. However, if we send a UDP packet to a closed UDP port, we expect to get an ICMP port unreachable packet. This indicates that the target system is up and available. In the following figure, we see a UDP packet sent to an open UDP port and not triggering any response. However, sending a UDP packet to any closed UDP port can trigger a response indirectly, indicating that the target is online. Nmap PU SN target UDP packet ICMP type 3 code 3. UDP port is closed. This leads to ICMP destination unreachable port. The syntax to specify the ports is similar to that of TCP. Syn ping, a TCP ACK ping. Nmap uses PU for UDP ping. In the following example, we use a UDP scan and we discover 5 live hosts. And it's showing us right here on this pen tester terminal what it is talking about. Let's inspect the UDP packets generated. In the following Wireshark screenshot, we notice Nmap sending us UDP packets to UDP ports that are more likely closed. The image below shows the Nmap uses an uncommon UDP port trigger, an ICMP destination, unreachable port, unreachable error. Masking. On the side note, masking uses a similar approach to discover the available systems. However, to finish, its network can quickly masking. It's quite aggressive with the rate of packets. It generates the syntax in a quite similar /p followed by a port number list or range. Consider the following examples. Masking and the machine IP /24/p443. Masking mash. I'm just gonna let y'all read that, guys. But yeah, masking is not installed on the attack box. However, it can be installed using an apt install masking. Which TCP ping scan does not require a privileged account? That's TCP syn ping. Moving on to the next one. Which TCP ping scan requires a privileged account? That's TCP ACK ping. Moving on to the next one. What option do you need to add an Nmap to run a TCP syn ping scan on the telnet port? And that's /PC23. And we are good to move to task 8. Alright, moving on to task 8, using reverse DNS lookup. Nmap default behavior is to use reverse DNS on line hosts because the host names can reveal a lot. This can be a helpful step. However, if you don't want to send such DNS queries, you use /n to skip this step. By default, Nmap will look up online host. However, you can use the option /r to query the DNS server even for offline host. If you want to use the specific DNS server, you can add the //DNS/server DNS server option. Answer the question below. We want Nmap to issue the reverse DNS lookup for all the possible hosts on a subnet, hoping to get some insight from the name. What option should we add? And that's /r. Alright guys, moving on to task 9, summary. You have learned how ARP, ICMP, TCP, and UDP can detect live hosts by completing this room. Any responses from a host is an indication that it's online. Below is a quick summary of the command line options for Nmap that we have covered. So I'm not going to go over all of them. I'm going to just let you pause and read up on them yourself. So remember to add /sn if you are only interested in host discovery without port scanning. Omitting /sn will let Nmap default port scanning the live host. Same thing goes here. I'm gonna let y'all pause and read through it as I turn this alarm. So moving on to answer the questions below, ensure you have taken note of all the Nmap options explained in this room. To continue learning about Nmap, please join the room of Nmap basic port scans, which introduces the basic types of port scans. And all you got to do is type in completed, and we have successfully finished this.